Welcome one and all, Precalculus12. Welcome to the help session of the first unit. We have Eye of the Tiger playing today, and man, what could be better on a Tuesday night? On a Tuesday, and Love and Life. I think it's Tuesday. Yeah, it is Tuesday. Welcome. Trying to get a good introduction there. See 5 viewers. Hey, look at this. We're stepping up tonight. 6. It just keeps increasing. This is too good. Hey, welcome. Thank you so much for showing up, whether you're watching live or whether you're watching just simply whenever you feel like it, before the test or even after the test if you want to just watch it again. Hope you're having a good time. You're going to see through this YouTube video. First of all, I hope it's helpful. If there are any technical difficulties, please make sure you text me. I want to make sure I get that. And the questions should be over on my right side as you're looking. And on that right side, you should be able to attach any questions that are there through that YouTube video. Anything from topics, anything from question numbers. I've got them imported up here. And we're just going to get started. We're going to go right straight into it. I said the first about 30 minutes, could be give or take, is strictly on identities. And so I want to make sure I go through those with you and make sure that we dissect them one step at a time. So here's the thing. You're not going to see them a whole lot. You're going to see more of my screen. But we're going to have an absolute blast. Because it's Tuesday, we get to do math. I mean, what other better things we could do with our time? This is absolutely awesome. Glad that so many people showed up. Glad so many people are using it. So I hope this is helpful. And if you got any ideas to better, let me know. I'm all about bettering it there. So let's do this. I think I've got my, there we are. I'll pull this over on this side. By the way, Eye of the Tiger, you cannot not get hyped. You know what I mean? Like, it's one of those songs, like, I'll hear, if you just played that in class, like, I'll just start, like, dancing. I mean, I'll start going crazy. I'll go through a brick wall. It's just like one of those things. You know what I mean? Man, gotta love it. All right, so here we go. A first review for our Pre-Cal 12, Unit 1. And we're going to go through those questions, and I want to make sure I pull up. The biggest thing is I want to make sure I pull up my perfect. All right, sweet. Jackson's in the house. Let me give a little shout out, by the way. If you leave a comment, I will give you a shout out. Just because I want to, just because I want to there. But let's get started. I'm going to go on this side. I hope. Again, if for some reason it doesn't work, sometimes there are little technical things, please let me know in the comment sheet, or better yet, text me, email me, whatever works there, okay? Cool. So I'm going to be able to see these comments on the right side. And I just wrote Gucci on the right side just to make sure that everyone's in here. And feel free, put those questions on the right side. And I'm going to get started with identities. Now, these are not on the review, and I get that probably maybe some of you want or were expecting me to do ones that were off the review. I can definitely do some that are, so feel free if you are one of those people that want me to do that. But I wanted to do some different ones, mainly to see if you could do them yourself. So here's what I'd recommend. If you are one of those people that struggle with this, maybe you watch 1 or 2 and then try some yourself. I think that might be helpful as we look to match the left side of the equation to the right side as we see up here. Now, there are a couple that you'll need to know, not identities, but more or less ones that if you went to the review, the ones that didn't have the other side on them. I think we did this one today and then this one today as well. Just making sure that you understand kind of what's expected, how can I simplify, and get that and go from there. But needless to say, I wanted to do some new ones, and that way we could kind of take it step by step. So 33, in fact, I always like to approach it this way. There's a couple of strategies that make this much easier than what it really is. And it's more or less just doing different strategies and recognizing that maybe the easier versions of it correspond to different and specific problems. So like number 33, the first thing that I go through with any of these is I say, is there anything squared? The reason why is if there is, then I look and see, do I have a Pythagorean identity that matches up to what I see here? For instance, the one that we did in class today was a good example. So I always look at that first because as you could see on the top, tangent squared plus 1, that equaled secant squared x, because that's an identity. That 1 plus tangent squared is in fact secant squared. And so my first step is simply to see if anything's squared. The second step that I would say that I would kind of go hold to is, can I multiply something? Like, can I simplify it? So a good example is if I have something that is back to back like this, a good way to simplify is to distribute the 1 to each of these and the cosine to each of these. Find that to be very helpful. And then the third, when in doubt, go to sine and cosine. Again, those are 3 good steps as we do some of the more basic ones. We'll do harder ones later on in the year, but these ones are ones that pretty much will follow one of these 3. We'll square, you do the Pythagorean identity. I'll put that here. You'll do the multiplication or the sine and cosine of that when in doubt. So I look at number 33 and I notice that there's nothing squared. There's nothing that I can distribute or multiply out. So I decide that number 3 is the best option. I'm going to convert tangent and cotangent into sine and cosine. So when I have tangent of theta, cotangent of theta, I'm going to match that up to 1 is the goal. So to do this, I'm going to change tangent to sine of theta over cosine of theta. And I'm going to hold on to that. And cotangent, and by the way, these are all in the identity sheet. Again, the ones that can go to sine and cosine, those are the ones that are really needed here. And then obviously cotangent, if you look on that sheet, goes from cosine of theta over sine of theta. So what this does now is kitty corner, these cancel and cancel here because it's multiplied. Now, if it was added, we would not be able to do that. But because we multiply them, we could cross cancel, leaving us with nothing and nothing. So it's really 1 and 1, and that's how I get a value of 1. And so my final step is I just simply state that 1, in fact, equaled the 1 on that side, okay? All right, good. I don't see any questions there on that right side, on the chat side. I see a lot of people watching, about 8 people. So if you do have any questions, if I'm confusing you, please let me know. You could even pause the video and come and fast forward as maybe you start trying some and then kind of go from there. All right, 35 is another good one. As I look at this one, I'm looking and seeing how can I simplify. And all those funky symbols, you could replace that with theta, my son's middle name. You could always do that. That's always an option there. And so this one on 35, we're trying to get to sine of theta. Again, is there anything squared? No, there's not. Is there anything that I could distribute and multiply out by? No, I can't. So tangent turns into sine of theta over cosine of theta. And since cosine's already in sine and cosine form, I'm just going to leave cosine of theta and just place it over 1 like this, okay? Because I don't need to change it to anything because it's cosine, right? And now we cancel out the corners, a little cancel party. Woo, woo. We end up getting sine of theta, and it equals what I was trying to get to, which was sine of theta on this right side. So we just say sine of theta equals sine of theta, and there we go. So my wife just stepped in the house. What's up, babe? I've got 8 people tonight. It's a party over here. This is good stuff. Big crowd. No sarcasm there. No, that's quite a few actually. So, all right, so that's good. That's 35. Let's go to 37. Again, we're just kind of going step by step through these. Let's go to 1 plus cosine of theta. So we'll kind of put 1 plus cosine theta here and 1 minus cosine of theta. While I write this, if there's anyone from Sweden out there, my Sweden followers, thanks for showing up. I got people all over the nation over here. It's good times. All right, first step is there anything that is squared? No, there's not yet at least. And so I know that I'm trying to get to that right side. So what we can do here is we could distribute this. And so just so you can see this here, I usually take the first value and just simply distribute to both. So 1 times 1 obviously is just 1. 1 times negative cosine is negative cosine theta. And make sure you show work too. That's a big thing, like I'm doing here. Cosine of theta times 1 is positive cosine theta. And cosine of theta times negative cosine theta is negative cosine squared theta. Okay? Now again, once I do that, that's part of the distributing and multiplying out. I have a positive and negative cosine that's gone like a freight train, gone like yesterday. And what I have now is 1 minus cosine squared of theta, and there I am. So 1 minus cosine squared of theta is what I have set up as. And now I go back to my 3 because I'm stuck now. So I've multiplied out, but if I go back, I can remember that if there's anything squared, I look at my identities. Well, my identities on the sheet that I have includes a cosine squared. In fact, the identity that's given to me is sine squared plus cosine squared equals 1. Is there any way, and I really like Dora the Explorer, I want you to yell at the screen right now, okay? Some people may think you're weird, but that's okay. Everyone thinks I'm weird. So do it, all right? What do I do with this green box to match up to this side or to match up to 1 minus cosine squared theta? I want you to yell at the screen. Very good. Nicely done. We can do this by subtracting cosine squared on both sides. So again, this is just the identity piece. So what we get now is sine squared of theta equals 1 minus cosine squared of theta. So what I can do is sine squared is the same as 1 minus cosine squared. So literally I could substitute sine squared of theta by my definition, by Pythagorean identity, and note that sine squared is in fact equal to 1 minus cosine squared, and that would be exactly the number, or the value rather, I'm trying to get on 37, okay? All righty. Oh, Jeffrey Blake's in the house here. Yeah, that's a good question. Jeffrey had a good question. What if there is no one watching? Do you still keep? Yes, I talk to myself a lot. And so when I'm by myself, I'll talk to myself. So sometimes I will keep it going. So does a tree make a sound if it falls and there is nobody around? That's a good question. That's more of a theological question. I would love to answer that. I think we could maybe use the Bible at Waffle House to dissect that. So that'll be TBD. Okay, we'll get that later. All right. All right. Check out number 39. These make me so giddy. I love these study sessions. By the way, I don't know why. My wife thinks I'm crazy with some of the things. Yep, she said yes, but it's okay. Which is a good point, ladies and gentlemen. That sometimes when people think you're crazy, you keep going. You just keep going. She said that means you are. All right. So 39. We'll go through our steps. We'll start with, that got me. That was pretty good. We're going to start with our squared first. We know that obviously the squared is the first part, but there's nothing squared. So we go to the second part, which means that we're going to distribute. So we're going to take secant and multiply by secant. Same idea. Secant times secant is secant squared. Secant times negative tangent is negative secant theta tangent theta, okay? And then my second part I have is my tangent. So tangent times secant. Hopefully this makes sense. I'm just distributing. Tangent times secant is, I'll put it down below, positive tangent theta secant theta. So we just put them together like so. And tangent times negative tangent is negative tangent squared of theta. So all of this, when laid out, can be simplified because as we look at this here, we see that, well, the secant of theta, tangent theta, is negative, where 1 is positive. So those are gone like a freight train, gone like yesterday, to where we get secant squared theta minus tangent squared theta. And what we're trying to do now is trying to figure out what we can do to simplify that left side. Well, as we look at our identities, that's a small box, I'm sorry. There we go. All right, there we are. There's the bigger box. There we go. And you'll notice that we go back to our original 3. So remember squared, right? Then multiplying, and then sine and cosine. A lot of times people go straight to number 3 when in fact it would be much easier to just start back over and see, once I see something squared, is there an identity for it? Well, in fact, there is. There's one that says 1 plus tangent squared theta equals secant squared theta. All right, like before, I want you to yell at the screen, what do I do with this identity that's given on the test? By the way, this is on the test. What do I do to this to match up to this? I want you to yell it. Go, go. I don't hear all of you. Okay, that's pretty good. We're going to then subtract tangent squared theta, subtract it to both sides to get 1 is equal to secant squared theta minus tangent squared theta. And all I did was simply whoop to the other side. Do you see that? Whoop to the other side. Just subtract that little thing right there, that tangent squared, and then 1 equals this here. So once I look at this, I recognize that this actually is the same thing as what I have here, same sign, same values. And so what I can do is substitute 1 in for it. So therefore 1 equals that right side, which was 1. Okay. Good stuff. Good stuff. Let's see if we have any other questions here. I don't see any other questions. Good. There are 10 people watching now. This is extremely exciting. Revolutionary. Only half of those are Sweden fans. Sweden people from people from Sweden. Sweden people. That's right. Swedish. So 39 is done. I do not believe 40 will be one that we need to look at. There. 41. Let's do one of those, okay? Let's just do one of them. And the reason why I want to do one of them is just so, just in case. I don't think it's going to be a lot of ones like this on here, but you can't ever be too safe. I think this one was on your homework, actually, and so it might be just a good one to go on, okay? Trying to get to cosecant and secant, so you kind of see that idea there. I go through the same thing. So number 1, I look and see, do I have anything squared? Nope. Got nothing. Number 2, can I multiply? Nope, I can't multiply. Number 3, sine and cosine. Well, it's already got sine and cosine, so we're actually good there. So there's kind of some other strategies that kind of fall below this. One of which is you just kind of have to recognize the fact that when we add something, we have to get a common denominator. So where the cosine is, we need a sine, and where the sine is, we need a cosine. So what we can do here is multiply this by sine of theta. What I do to the bottom, I also do to the top. And on this is missing a cosine, so we'll put a cosine here. Got to give some love to the top. So what we have here is that the top part has 2 sines, giving us sine squared theta, 2 cosines, cosine squared theta, and it's all over my common denominator of sine cosine, or you could put cosine sine, it doesn't matter. So sine cosine, and there we are. So the question is now, is what can I do to simplify? Well, again, I look at the fact that there's something squared. So I kind of come back to the top here and I say, is there any identity that includes, that could simplify this top part? Well, in fact, there is. There's one that says sine squared theta plus cosine squared theta equals 1. So what we can do is substitute 1 in for sine squared plus cosine squared. So what does that do? Well, this produces 1 on the top over sine theta, cosine theta. And at this point, what I would do is, and by the way, this is an identity. I'm sorry. I'll put that in. Bad coach, Jay. Sorry, coach. Sorry, y'all. Let me erase that. Give a little whoop whoop. Give a little whoop whoop for today. Can you do that right at home? Just give a little whoop whoop. Good. Nicely done. All right, so once I do this 1 over sine and cosine of theta, I can look over on the right side and recognize that this is where I was going to. So 1 over sine of theta and 1 over cosine theta. Well, 1 over sine of theta is cosecant of theta, and 1 over cosine of theta is secant of theta, and that's how I get to the answer that was on that right side. I'll be honest, that's a tough one. That is a tough one. Sorry, get some water. So yeah, that is a tough one there. I would say there really won't be a lot of those, to be honest. That falls outside of the 3 steps that I kind of set up there. But just be leery of, if you have 2 things you add, they need a common denominator. We need to do that first before adding them there. Okay. All right. Any questions here? I'm gonna skip 42, and I'm gonna go to, let's see here. I saw some good ones. Oh yeah, something that's not on the review. Let's do this here. Let me actually get something here. Let's see. Erase this. Good. Okay. Let's give one here. This one is on the test, and I put it on the review for. When did I put that on the review? I think it was on Monday when we did our, it was like where you texted in the Mentimeter thing. But this is good. This is good stuff. Okay, so let's pretend that cosine of theta is 2/3, and we want to find what cosine of pi plus t is, and cosine of pi minus t, what that one would be, right? So really we've got 2 things here, and to make this a little bit easier on us, the easiest thing to do here is to simply just see what pi plus t would be. Well, if this is pi here, plus t would rotate downward and be in the 3rd quadrant. And over here, and you might say, Coach, why is that? Well, remember, I imagine that t, we don't know what t is, by the way, but we're imagining t is in the 1st quadrant. So if that's true, if I took pi, which is 180, and I added t, that would push me towards the 3rd quadrant. If I had pi, again, t is in my 1st quadrant, we're pretending, okay? If I had pi and subtracted t, that would rotate upward and would go in that direction, okay? So this would be more pi minus t in this side. So the question becomes is if cosine of theta is 2/3, what happens when I take pi and add t, and when I take pi and subtract t? Well, what we could do is we remember that our acrostic of all short teachers care. Thank you all. This is true. I do care. And I'm short. That's fine. I admit it. Okay. So get off me. Okay. I'm tired of the jokes. All right. So as we go, I'm joking. At all short teachers care, we look right here and see what's happening here. Well, if right here, cosine of theta, or t in this instance, really we're using t, so we'll put t in, that this would be 2/3. The question is what happens when it's either in the 2nd or it's in the 3rd quadrant? Well, I look and see that, in fact, the only thing that is positive here is sine. The only thing that's positive down here is tangent. Cosine's positive in quadrants 1 and 4. So due to that, cosine would be negative in quadrants 2 and 3. Therefore, this would be negative 2/3. And so would this one, negative 2/3. We would leave that as is. Okay. Cool, cool. Again, that's a good one to just kind of look over and do. Go back to the homeworks and check those out. Those are really, really good there. Okay. Are y'all still getting my stuff coming through? I hope so. I hope it's still coming through. As we look towards the comments, please make sure if you got questions, throw those out there. I know that a lot of this stuff is tough and may take a little bit. So if you've got questions, throw them out there. I did see this one. So this one's a little weird because this one is cosecant of pi over 2 minus theta. you've seen it as cosecant of 90 minus theta, but I hope that you know that these two are the same, okay? By rule, on the test tomorrow, you'll have this, by the way. By rule, that this equals secant of theta. So does this one, okay? So since these equal secant theta, because they're the same thing, if I said find this, really what I'm doing is finding what's equivalent to it, which is secant of theta. So if I recognize that secant of theta equals 4, then cosecant of pi over 2 minus theta is also 4. It's a little strange because it's that easy for this one. But sometimes you have to create a triangle, and then they'll ask this part of it. Just kind of be leery of that. Pi over 2 minus theta. When you do that, just make sure you write down the definition right. You should be Gucci. Should be Gucci there. Good stuff. Would T ever not be in the first quadrant? Yeah, that's a great question. Technically, I always say it is in the first quadrant. Yes, it's possible that it wouldn't be. I don't think I would get, well, I won't do that to you. The reason why that would be the case, let's say, and I'm just giving you a for instance, this is not a test. So fast forward me if you're like, coach, shut up. Okay. So if I said cosine of T is negative 2/3, I could not assume that it was in the first quadrant because all are positive and this is negative, right? But what I could do is say, okay, instead, where's cosine negative? Cosine's negative in the second. So I'm going to make T something between 90 and 180 or in the second quadrant because this is all short teacher's care. So that's why this would be, the only thing positive there would be sine. And so that's why this would have to be in the second quadrant if I gave the fact that it's negative. Good question. Good question there. So I did 15. I'm kind of going backwards a little bit. Remember the gangster sign? Gangster. I just said gangster. Gangsta sign of theta with the little tick mark of it. That just means that it's the reference angle. Okay, so make sure you're clear on that. Remember, reference angle refers to like negative 321. If I found something coterminal, I add 360, producing 39 degrees, right? So, hold on, did I say that right? Yeah, 39 degrees, sorry. So 39 degrees would be in the first quadrant here. The question is how do I create the triangle? Well, it's connected to the x-axis, and theta corresponds with the origin, right? So if this is 39 degrees right here, okay, the question is what is the reference angle? Well, the reference angle is what, when we create the triangle, what theta is. So that's why this would be 39 degrees within the context of the reference angle here, okay? All right, number 12. Again, these identities I'll give to you. This one says find sine of negative theta, okay? By rule, and I'll write this down here, sine of negative theta equals negative sine of theta, okay? We went into the why behind that earlier. Really, I'm not going to do that here as much as just make sure that we know how to execute this. So we know that this is our triangle, cosine of theta equals 15 over 17. So we draw a triangle here and here. Here's theta. We know 15 would be my adjacent side, and 17 would end up being my hypotenuse. So when I do 17 squared equals 15 squared plus x squared, my goal is to solve for x, and when I do, I believe, check me on this, I believe I get 8. So this right here would be a value of 8. Now, I don't know the fact that it is in quadrant 1, but when it doesn't say, we're going to make all the values positive, which would be the same as putting it in quadrant 1. Sorry, man, got it. All right, my fault. So then I look and see, okay, so I'm trying to find this, right? So I look on the right side. What is sine of theta that I could plug in here? Well, if sine of theta is opposite over hypotenuse, that would be 8 over 17. So really 8 over 17 can get substituted in for sine of theta. We'll add a little negative on the outside here, getting me negative 8 over 17. And that would be the value that we'd be looking for that's equal to sine of negative theta. Cool. Cool beans. All right, real quick, I want you to try this one. Let me see what quadrants this terminal side in. Let's see. Actually, I'm gonna go through how long have we been going right now? Oh man, we've been going for about 30 minutes, I think. 30 minutes already. Gotta love it. All right, so here's what I want to do real quick. Look through your review. I'm gonna get some coffee because my throat is killing me. And literally, it's already ready, so I just need to go pour it. We're going to do this one tonight. I want to go over this one again just to make sure we know the setup really. Also, with these right here, both of these, coterminal, right? Subtract 2 pi, get a common denominator. That's huge. Over here, I'd add 2 pi because it's already negative. But I think we've already done that. I think, yeah, this one I definitely want to hit on. We already did this one up here, so we're good there. I want to just hit on the principle of number 7. I do want to hit on that one. Coterminal, we should be good. Just make sure you keep it in radian form in terms of pi. We're going to do this one on the last side, so we should be good. You could throw out this one. Okay, throw out that one. It's a little tough. I'll throw that one out. And number 2. So these are the ones I'm going to hit on. If you have any other ones that you're like, Coach, this would really be a good one to go through, please let me know. And I'm just going to take like a 30-second breather, get some coffee in me, and then we'll go from there. Cool. So just check that out. Put a little comment on that side. You could skip this, pause it, whatever. Maybe you want to try it. That would be really good. But I'm going to give just a second, and we'll come back to it. Cool. Cool. All right. So for those of you that are out there, hopefully, is this still going? Oh, please, still keep going. Yes, I think we are. Do this for me. Hey, would you mind doing me a favor? Could you just say, could someone just say, can you see my screen right now? If someone could throw that out there. I don't think I paused it or did anything. Let me see. So I'm still screen sharing. I think that's right. Y'all see me? Someone throw that out there real quick. Or do you see like my image? I think I'm try to restart this. All right, perfect. I think we're good to go. It's still going. Good. Okay, perfect. So again, I do still see that there's about 10 of you still out there watching this. I want to go over specific questions. I've just been kind of going through random stuff, but at the same time, I want to make sure it's relevant to you. So if you know, if you got questions, throw them out there. If you're just like, man, I'm just along for the ride, that's cool. Absolutely cool here. I will say, as I'm setting this next problem up, I'll be honest, this year y'all have been absolutely phenomenal. Just in the way that y'all approach just class, and like I've just had I've never had in my years of teaching so many questions and just people helping each other out, and that's to y'all. And man, you know, we got the best teacher and the best students that are here, man. That's a perfect combo. You know what I mean? And just appreciate that. I really, really do. Really, really do. So great work there. Keep it up. Keep up the good work, and we'll rock and roll. Okay. Let's look at this one now. We've got this idea of sine is -3/5. Well, with sine being negative, I think we did this in class today, but I wanted to make sure it was on a podcast. Remember that when sine is negative, that would be in the values of tangent and cosine, right? And that means that 3 and 4 are the quadrants that we're focused in on. We then look and see where is tangent greater than 0, or where's tangent positive. And we could recognize that tangent is positive both in quadrant 1 and quadrant 3, right? So if it's in quadrant 3, we know that this would be like the terminal side here, okay? And what would happen is we create the triangle by connecting it to the x-axis and providing ourselves with a theta to be referenced from, right? That's why we call this a reference angle, because it's the angle closest to the x-axis that helps us in determining what the other sides are and what the ratios are. So then -3/5, obviously that's the opposite side, and that's the hypotenuse. And if I did the Pythagorean theorem, I would get 4, but since it's to the left, we would make it negative. But then from here, what we could do is just find what the trig ratios are of sine, cosine, tangent, and that sort of thing. And that allows us to be able to dissect those 6 trig ratios like we did in class. And so I hope that was helpful. Hope that's helpful for you just in seeing that setup that's there. Jackson asked this: if the pi plus or minus t is the only stuff that is on the test that is not on the review sheet, it's a great question. I can't guarantee that, okay? Because the review sheet is comprehensive. It's pretty much everything we've gone over. I can't say everything, because if I bind myself to that, if something shows up that maybe was on the homework or something, I will say that everything that is on the test is either on the review. I would say 98% of the stuff is on the review, with only 2% of it possibly, could be 100% by the way, but 2% possibly that's on the homework but not on the review. So I don't know. You would get, if you knew everything on the review and did it perfectly on the test, you would get a high A. So I don't know if that helps you at all, but there's not going to be a whole lot of surprises there. The unit circle is one thing that maybe I didn't really include on there, but again, I'm not really stressed out about that. It's something that y'all do a great job with anyway. All right, 2.25. Again, with 2.25, we remember that 0 to pi is our radians here, which is also the same as 0 to 3.14 radians. When we talk about the context of radians here. The toughest part to remember is with 2.25, just to remember that this is 3.14, because if you know this, it makes the radian of 2.25 much easier, to where you could see that if I drew it in standard position with the initial side being on 0, my terminal side would be somewhere between this halfway point and 3.14. And it'd be somewhere in there. And so this would be standard position. We'll call this theta, this angle right here. And that'd be the angle in standard position. And so we would just say the quadrant angle would be 3. If I divided this by half, just in case you wanted to know, this would be 1.57 radians. And add 1.57 to here, you get this here, and so on and so forth. If you forget that, just multiply 3.14 times whatever's on the unit circle. So this is pi, that's easy. But with 3 pi over 2, just multiply 3 times 3.14, divide it by 2, and that allows you to get what it is in terms of radians. Okay. Savannah, thanks for your help there. Appreciate you. Savannah says, I'm having trouble with the second problem on number 8. Well, let's check that out. Thank you for putting that out there, because that's a good one. Is it this one, Savannah? Is this the second one? I apologize. I didn't really number these. Is this it? Could you just confirm that real fast? If you could, I'll hold off for just a second. But I think it's that one with the sine squared. The one that's there. Kind of hold off just a second. I know it's lagging just a little bit, but it's I'll start on this one, and if it's something different, we can go to the next one there. But this one says sine squared plus tangent squared. This is a tough one. Plus cosine squared equals 1, right? And actually, what I'd like to do is just kind of take this and just kind of whoop, put it up on the top. I'll come back up to that top one. But once I look at this one again, I'm going through the same process. Perfect. Thank you, Savannah. So I'm going through the same process of first figuring out, are there any identities that are squared that we could simplify? Well, we recognize that we do have a sine squared, we have a tan squared, we have a cosine squared. But it's so there are pieces to this, but the identity that includes two of the three in there is this identity of sine squared plus cosine squared equals 1, right? With thetas in here. So what I could do, even though this is not in order, there's a thing called commutative, which is just a fancy name of saying that I can rearrange addition to be able to match up this, because it would be the same thing. So when I rewrite this, I can recognize that through my identity, through the squared option, that sine squared plus cosine squared is in fact the same thing as the value of 1. So when plugged in, I could put 1 in for sine squared plus cosine squared. And then I look one more time and I say, okay, is there an identity that is on the left side that I could simplify that includes a tangent squared? Well, oh, it's not 1. I was like, good night. That's really bad. It's actually secant squared. Sorry. Wow. Secant squared. I was like, this is not going to work. I messed up. But this is the part that we're trying to match up to. My fault. So then I go to my identity, and there's another identity, and I'll circle it so you know it's not actually part of the problem here yet. But 1 plus tangent squared equals secant squared theta. So guess what? It's exactly what we just got. That 1 plus tangent squared by my Pythagorean identity is in fact secant squared, which matches up to what my original answer or value that I was trying to get to was. Okay. Savannah, great question. I love that question. That's good stuff. Good stuff there. I wanted to also dissect this one mainly because I said I would do it in class. And that's cosine of theta, secant of theta minus cosine of theta. Okay. Now, if you can do this one, you're Gucci. You're Gucci if you're starting to get on that right track there by doing this one, because there's nothing that it's really equal to, and there's doesn't seem like there's a whole lot of strategy. So let's just go through our 3 steps. So number 1, is there anything squared? No, there's not. Number 2, okay, we'll go to that one. Can we multiply? Well, in fact, there's a parenthesis, right? Which means that the cosine theta, because it sits on the outside, goes to both of these that are here. So if I were to distribute this, let's just see what happens. We get cosine theta, secant theta, minus cosine, and since there's 2, we get cosine squared theta equals whatever is on we're trying to get to. Now the next step we do, there's nothing still squared. Well, there is here, but you'll notice if you went to the squared part, you'll notice that sine squared plus cosine squared equals 1. And so there's nothing that I could take here that could be simplified yet. What I could do, though, is change secant into our third option, which is in terms of sine and cosine. So changing secant to 1 over cosine is what I'll do here. And what I'll do then is cancel to get 1, value of 1. So 1 minus now cosine squared, because I brought it down, did not simplify. And that's where here I could then look back up and say, oh, I remember, we actually did this on another one, that if I subtract cosine squared on both sides, I get sine squared based on my identity is equal to 1 minus cosine squared. So 1 minus cosine squared is actually equal to, and I'll just rewrite this, sine squared of theta. That'd be my focus there. That's what it would be equal to. Now, ones that I don't give you an answer for, I'm going to be more lenient on in providing credit, mainly because you don't know how far you're going. But I would say just take it as far as you possibly can, and that should help you out there. Okay. All righty, we're headed towards our final few. We got actually 2 more. okay? I want to do the S over R equals theta last, okay? This one says cosecant of theta is equal to 2. Okay, so, and the answers are in terms of degrees and in radians between 0 and 360. So the question really is on my unit circle, what would be the degrees that corresponds to the value of 2 for cosecant? So maybe the better option is to convert cosecant to its reciprocal version of sine, because cosecant and sine go together. So sine of theta is equal to, let's find the reciprocal on the right, which would be 1 over 2. Okay, sine of theta is equal to 1 over 2. So is there a value or two values that's on my unit circle that have a sine of 1/2? Well, I know it's in the first quadrant and in the second, because that's where sine is positive. And if I looked at that unit circle, and because I don't have it, so I'm trying to think through that there. We should be able to get 30 degrees and 150 degrees. So that's in degrees. And then make sure I follow instructions. Put the pi's out there, pi over 6 and also 5 pi over 6 as well. So that is where sine is going to be, or going to have a value of 1/2. All right, here. Last question, unless you have other ones here. The question is as follows. There is a central angle, angle in the center of a circle, that has a theta measurement with an arc length of S and a radius of R. If I give you 2 out of these 3, you should be able to find the third. It's kind of the idea here, where S over R is equal to theta. Now, as I look at this, I note that there is a 7 for my radius, so I could actually substitute that in. And the measurement I am looking for is finding the length of the arc, so we're really looking for S here. And the angle measurement, which is the theta, is 135. The problem is 135 degrees cannot, please say cannot right now. Yes. Tell your parents right now. Say it right now. Cannot. It cannot go in as radians. It's got to, or I just messed up. Sorry. Wow. I was so passionate. It can't go in as degrees. It must go in as radians. And so 135 over 1 has to be multiplied by pi over 180. Now, once I do that, 135 multiplied by pi, let's see here, 3 times 3. I'm sorry, I simplified it first. And then I'm going to take that. And again, I'm just trying to get this here. I'm going to divide that. Okay, no. Okay, I got 2.355 is what I got. And 2.355. Hold up and make sure I get this right. Yeah, so 2.355 is what theta is in terms of radians. Okay. I then will take this, substitute it in for theta. I then will multiply both sides by 7. 7 times this is approximately 16.5. Now, there is no inches or anything like that. But what that means is that this is the outside of the arc. So if we were saying inches, we'd just say the arc length is 16.5 inches. Okay. Make sure you keep it in radians and you will be Gucci. You'll be Gucci there. Okay. All right. How we doing? How we doing over here? Sweet. Are there any other questions that I can do for you? I hope not. I hope that we just rocked and rolled on this. I've got my mug. Oh, I'm sorry. There we go. Got my mug. You like it? And this is the front. It's Starbucks, a little blue and yellow. It's on purpose. I think we did a it's supposed to be trademarked, but I think I stole it. I'm sorry. Actually, a student gave that to me. So he stole it, not me. So just saying. But as we wrap up tonight, I hope that I'll just kind of give you a motivational. Do your best. Do your very best. That's all we ask for. No matter what. I felt like we really did prepare well for this first unit, and man, I look forward to this senior class. I was talking to y'all's parents last night. I was telling him, I said, hey, as far as just everything, everything goes, the attitude and just positivity from the senior classes is legit. And so I appreciate y'all. Thank y'all. Love y'all. And I'm going to be there tomorrow from 7:30 to 8:10. So show up. 8:10, I usually stay longer, but I've got the this prayer thing for Break Every Chain 2.0. And so I'll be doing that tomorrow as well. Let me check to make sure that there's any other questions. It looks like we are Gucci. I am going to post this on the top of the on-campus page, but you can access this at any time, and you could rewind, pause, whatever. It's a great day to be a Spartan. See y'all. Bye.